The purpose of this lesson is to learn how to introduce logic into your programs. We're going to start using if and if-else statements, and we'll also learn a shortcut way to use those called a switch statement. We'll learn how to use conditional operators and how to use the not operator, and also how to avoid some common errors that will occur when you make decisions, and also how to do decision making in GUI-based programs. When we build our programs, we're going to start using what is called pseudocode and also flowcharts, and these will help us understand what the program is actually doing. Now, the reason that you need to understand how these work is the textbook uses these conventions to show you what the program would look like without actually giving you the code for it. So the first thing is called pseudocode, and what pseudocode is something that looks like syntax but really is not syntax. So simply plain text. It's designed in a line-by-line manner just to allow us to see the way that the program should function without worrying about what the actual text is that we have to type into the IDE to make it work. You can also use a flowchart, which a flowchart uses symbols to make decisions and to show you all the steps throughout the program. One of the things you need to be aware of is in a flowchart is an item called a sequence structure. Now what a sequence structure is, it allows us to go through and follow one step at a time how our program is actually going to work. So in this example we have a sequence structure. So we have where this person is supposed to go west on this road, turn left, then enter the expressway, then they're supposed to exit, then they're supposed to proceed. These are the flowchart sequence structures. Notice the arrows here just simply point from one sequence structure or one symbol to the next. Over here on the right, this is more like pseudocode. Now pseudocode, like I said, is just simply going to be the plain text line by line of what the program should actually be doing. The whole purpose of these is to make it where we can see what the program is doing without actually sitting down and typing it into the IDE. Remember, you should be spending more time actually designing the program than it should take for you to actually code it. We're going to be making some decisions, and we're going to use a thing called a decision structure. Decision structure looks like this, and what it is this diamond here. So we go along our program and it's step by step by step until we get to here, and then it has to make a decision. And we have a value here called a conditional, and the conditional is going to be the decision maker of if something is true or false. And on every one of these you'll have two sides. You'll have a true side and you'll have a false side. Now the true side means that if the item is true, then we're going to do something. And sometimes that will be all that you have, is just that if it's true, do something. Sometimes you'll have if it's true, do something, but if it's not true, then do something else. If we have something where we just simply look to see if something's true, that's called an if statement, or what's called a single alternative. If we have something that's true, else do something if it's false, then that's an if-else statement, and that's also called a dual alternative. So in this example here, is the expressway backed up? If it is, we go to the true side, and then we do these steps. If the expressway is not backed up, then we go to the false side and do the stuff over here. This is a dual alternative. Like I said, it has two possible outcomes. Alright, so we're going to start making if statements, and we're going to use what's called a block. Now what a block is that our if is just simply testing to see if something is true. And if it is true, we're either going to perform one line of code or we're going to perform more than one line of code. Alright, so we have this issue here is the number less than 5. If it's true, then we go to this side and we write A on the screen. And what you'll see is it looks like this. It says if the number is less than 5, then write A on the screen. Now you'll notice that this is indented here, which means that this is the true side of this if statement. Now in C#, it'll allow you to do this if there's only one line of code to be performed in the if statement. However, the problem is that if you try to add more than one line of code, let's say I wanted both of these things to occur, if this is true, it will only perform the first one. Alright, so some things you need to consider. An if statement does contain something else, so therefore there will not be a semicolon after the if statement. And so the way that it works is if this thing inside of the parentheses is true, we're always testing to see if it's true. So if this is true, then we do this. And then in this case, there's no else statement here, which means it will always write line B here. So be real careful with your if statements. If you put a semicolon right here, it's the same thing as having nothing inside of your conditional statement. inside of your selection statement, and then still performing A and B, and we don't necessarily want to do that. Alright, so in this example, let's go back up to the prior one. If this is true, then we're going to do this one line of code, but if I wanted to do both of the lines of code, then I have to write it a little bit differently. Okay, so in this case, we're going to say if the number is less than 5, and notice we open up a curly bracket and close a curly bracket. And if you open it and close it, so open the curly bracket, press enter twice, and then close it, C# will actually line these up for you, and it will automatically indent the code to go inside of here. This is called a block statement. What this means is that if this is true, if the number is less than 5, then it will do both of these lines of code in here. But if this is not true, it flat out skips both of the brackets and everything that's inside of it and goes on to whatever else is left afterwards. Alright, so if we were to do something like this, if we were to say if number is less than 5 and then not use the curly brackets, it will only perform the first line. It will not perform the second line. It does it every single time. So if we want both of these lines of code to be inside of our if statement, we have to put both of these inside of a set of curly brackets. We can also use what's called a nested if statement, and what that is just simply taking one if statement and putting it inside of another one. Now, when we nest these, we have to use the curly brackets to make it work right. You can do it if it's a single line of code. You can do it without the curly brackets, but I'm going to advise you not to because you will very easily mess up your code. Alright, so what we're going to do is we're going to do something like this. We're going to say if this thing is true, we go to the true side, and then we go into another if statement. So then we get into this if statement. If it's true, then we write this number or this line of text out. Okay, if we come in and say it's false, then there's no alternative over here, so it just simply skips this section of code. Alright, so what you're going to do is you're actually going to put an if statement, and then the other if statement goes right underneath of it. Like I said, I would strongly advise using curly brackets here. So if this, and then open curly brackets, and then these lines of code go inside of those curly brackets. It'll become very easy to mistake what set of if statements belongs to which if command, and if you don't use the curly brackets, you can't force it to use one over the other. Alright, so we're going to still be using decisions here. So in our program here, we create a constant called high and low. We set both of those to a value. Remember, you can declare more than one variable of the same data type on the same line. We're making a string to hold a string. We're making an integer to hold a number. We're going to ask the user to enter a number. We read in whatever that they put into the line and stick that into the number string. Then we convert number string to an integer, stick that into number, and if the number is greater than 5, then it will go in here and look at this if statement. Now let's say they entered 3. If they entered 3, it would skip all the way to the end of this entire if statement. Okay, so the question is, where is the end of this if statement? And because they didn't put curly brackets in here, it's not easy to see. However, if they put curly bracket here and an ending curly bracket down here, then I could easily see what it would skip over. The other thing is if you're doing your coding in Notepad++, Notepad++ on the left side will automatically give you the little plus and minus symbol where you can actually collapse the entire if statement. It makes it easier to figure out what belongs to what. Alright, so like I said, we have dual alternative statements, and these are just simply ones where we have an if something is true, do one thing, else do something else. And they look like this in pseudocode. So if the number is greater than high, then we're going to go over to the true side. If it's false, then we go over to the false side. Alright, so your code will actually look like this. It'll say if the number is greater than high, do this code, else do this. Now if I have an if-else statement, one of the two of those is going to run. There's no option there. One of the two of those is going to run. So either this will run or this will run. But the thing that makes that decide is going to be this conditional statement right here. Alright, so in our code, it would just look like this. Same thing we had before, but like I said, we're going to start using the curly brackets because it will make it much easier to figure out where your code is. So if, and then all of this would be inside of a set of curly brackets, else, and then another set of curly brackets, and I will show you that later in this lesson. Alright, we can combine and or statements. So what I want to do is I want to start seeing, let's see if somebody is older than 65 or they're younger than 3. Maybe they get a discount. If I want to see if somebody's old enough to vote and they're younger than 21, then maybe they get a driver's license that's colored a certain color. So I can start doing that kind of thing. I can actually look at 2 conditional statements, and we're going to start using and ors. So an and operator just simply says if the first conditional and the second conditional are both true, then it's true, and it will do the if side. If either one of those is false in an and statement, then it'll simply go to the else side because it's false. All right, so what we can do is we can use what's called a short circuit evaluation. And what C# does, when we actually start doing our evaluations, it will always evaluate the first conditional first. And so in an and statement, let's say the first conditional is false, it won't even bother looking at the second conditional expression. So what we can do is we can short circuit it. And what that means is, let's say that I have 2 values and I know that one of those is almost always going to be false. Then what I want to do is I want to try to evaluate that one first because it'll make my code run a little bit faster. It makes it where I can actually simply make my program only evaluate that first one. And then if the first one is true, then we'll go ahead and evaluate the second one. I'll show that to you later. All right, so the and evaluations, they're going to be different than what you've seen before in the CIT 120 course. In CIT 120, and depending on what programming language you're using, you actually used and or. In C#, we either use 2 ampersands for the ands, or we'll use 2 vertical pipes for the ors. All right, so we have these things called truth tables, and what a truth table is simply looking at if I have 2 conditionals. All right, so let's say my first conditional is if you are older than 3 and younger than 18. I want to evaluate the 2 of those, and I type in a number 6. Okay, so older than 3 is X, younger than 18 is Y. All right, so I typed in 6. Is 6 older than 3? True. Is 6 less than 18? True. Therefore, it's all true. Okay, if I type in 21, was 21 older than 3? True. Is 21 younger than 18? False. So then it's false. If I type in 1, is 1 older than 3? False. Ooh, okay, this is what I was saying. The first one, if it becomes false, it won't even bother to evaluate the second one. It doesn't care if it's true or false. If this first one is false, no matter what, with an and statement, it ignores this one and it just goes false. But be aware that if you have a false and a true, or a false and a false, they both have to be true in an and conditional statement for it to be true as the outcome. All right, so your operator is going to look like this. We're going to say if the age is greater than or equal to 0 and the age is less than 120, then we do this. We can also do this as a nested if. Now this is the exact same statement. So if the age is greater than or equal to 0 and if their age is less than 120, then we write this out on the screen. They're both exactly the same statement. They both work exactly the same way. It will evaluate both of these, but this is just simply a shorter way to write it. We can evaluate both of those in the same line. We can also use or conditional operators. Now or is going to be if the first thing is true or the second thing is true, then we'll go ahead and treat it as true. Okay, so if I want to evaluate are you younger than 3 or older than 65, maybe you're getting a discount at the movie theater. So what I'm going to do is I'm going to evaluate the first one. If it's true, then the whole thing is true. Then I'll evaluate the second one. If it's true, then the whole thing is true. The only way that an or operator is false is if both of the things are false. Once again, we can short circuit it. It will evaluate only the first one. And so what we're going to do is we're going to evaluate, are you younger than 3, older than 65? Okay, so I type in an age of 2. All right, is 2 younger than 3? Yes, so it's true. Therefore, it ignores this one and automatically goes true. Okay, I type in a number of 2, and your age is younger than 65. So that would mean the first one is true, the second one is false. But once again, like I said, if the first one evaluates as true in an or conditional statement, then the whole thing becomes true. It ignores these 2 over here. All right, so then if I type in an age of 68, All right, is 68 less than 3? That's false. Okay, then it will evaluate the second one. Is 68 greater than 65? Oh, that's true, so the whole thing is true. If I type an age of 50, okay, is 50 less than 3? False. Is 50 greater than 65? False. Therefore, the whole thing is false. The only way you get a false with an OR conditional is if they're both false. The only way you get a true with an AND conditional is if they're both true. So be aware of these. These are called truth tables, and you need to know them. All right, so same thing. We can say if the age is less than 0, or the age is greater than or equal to 120, then we can say the age is not valid. And that's the same thing over here. We can say if the age is less than 0, then we're going to say the age is not valid. Else, if the age is greater than or equal to 120, then the age is not valid. So notice this is 2 lines of code up here. Down here you have 5 lines of code. So all we're doing is just simply putting the 2 conditionals on one line, separating them with either the AND or the OR conditional operator, and then that allows us to do it as 2 lines of code as opposed to 5. All right, so everything that we're trying to do is look for a Boolean expression. And now Boolean is just simply in this term meaning something is either true or false. Those are your 2 possible outcomes. And so our Boolean operators are the 2 ampersands or the 2 vertical pipes. Now the problem is that sometimes I can have unintended side effects. I can have something occur that I don't expect to. Maybe my conditional is not set right, or I evaluate for the wrong expression. And sometimes I may end up with something where I may not have any type of output like I expected. Let's say I'm evaluating if the person is old enough to vote and they're old enough to drink. Well, if you're old enough to vote and old enough to drink, then anybody over 21 is going to be true. But let's say I do something like if you're under 18 and old enough to drink, that's never going to happen unless they lower the drinking age. All right, so what we want to do is we want to make sure that any type of evaluations that we make won't necessarily come up with some sort of unintended output or something that really doesn't make any sense. All right, so in this example here we have that the age is 10, the rating is R, we have the child age is 12, we have the senior age is 65, and then what we're going to write out is that when the age is age, which is 10, and the rating is 1, which is R. All right, so then we're going to say if the child age is less than 12, or the age is greater than the senior age, 65, then, and the rating is G, then we're going to write out that they get a discount. Anything else would be full price. Now I want you to pay attention to something here. You'll notice that the OR statement here is in parentheses. And the reason for that is that your ANDs and ORs have an order of precedent. So what's going to happen is that it will automatically do the ANDs first. So if I didn't include these parentheses, what it would actually do is say if the age is greater than or equal to senior and the rating is G, or the age is less than the child age, which makes a completely different statement. So I have to control my ANDs and ORs with parentheses, and if I don't, then I will get some weird output that I really don't expect. All right, so what I want to do is I want to make my if statement shorter. We're going to start using what's called a switch, and what a switch does is allows us to use what are called cases. All right, so we can use a switch to test a variable, and we can do range checks. All right, so if you think back to CIT 120, you did range checks in there where maybe it was something like you wanted to find out what somebody's grade was, if they got a B or a C or a D or whatever. And so we started off, if the grade is greater than or equal to 90, then it's an A, else if it's greater than or equal to 80, then it's a B, else if it's greater than or equal to 70, then it's a C, else if it's greater than or equal to 60, it's a D, else it's an F. I'm hoping you've seen an assignment like that before, but that particular assignment would make it where you have to evaluate that over and over and over again. It's actually fairly inefficient. It's very easy to mess up your code in there because you have a lot of nested if statements inside of there. All right, so I want to do it a little bit differently. We can use what's called a switch, and what a switch does is it allows me to do the same thing as making all of my separate if statements, and they're all nested, But instead of doing that, then what I can do is just simply go one at a time. So I'm going to show you a couple of options for doing it without the switch, and then I'll show you with the switch. Now there's this thing called the no fall through rule, and essentially what that means is that if I evaluate it as an A, then what it'll do is it'll still try to test it for a B, a C, a D, and so forth. So I want to make sure that I can tell it when it finds the correct answer that it needs to stop trying to check the other ones. And so what we're going to do is use this term called break, and what that'll do is tell it, okay, if the grade is greater than 90, then we output on the screen the score as an A, and then the next line of code is actually going to be just simply the word break with a semicolon at the end of it. And what that does is tells it, hey, stop trying to evaluate. And if you don't do that, what it would do is it would go through and say, all right, the grade is A, then it tries to evaluate for B. Is it greater than 80? Oh yeah, it is, so the grade is B. Then it evaluates for C. It says, is it grade greater than 70? Oh yeah, it is, so the grade is C. And so what happens is our no fall through rule is that if I don't put my break statements in, the actual resulting value, no matter what the score is, would be an F. And we don't necessarily want that. All right, so our if statement would look something like this. So if the year is equal to 1, and then we're going to write out that the person is a freshman. Else, if the year is equal to 2, then we're going to write up their sophomore. Else, if the year is equal to 3, they're a junior. Else, if year is equal to 4, they're a senior. Else, we have an invalid year. All right, notice our evaluation there. Remember, it has to be 2 equal signs. 2 equal signs means it's a comparison operator. 1 equal sign is an assignment operator. So please pay attention to that. It has to be 2 equal signs. All right, in the case of a switch, now what I can do is I'm going to make a switch, and this is a data type, and we're going to call it year. All right, so then what we have are these things called cases. All right, so case 1 is to look to see if they're a freshman. Now case 1 is going to be the year. So that's the same thing as saying if the year is equal to 1. Year is equal to 2, year is equal to 3, and so forth. So if the year is equal to 1, then this is what we're going to do. Now notice this break. We have to actually put the break in here because what will happen is it'll go, if I type in that their year is equal to 1, then what it will do is it'll say 1, okay, here's 1, so freshman. And break tells it, okay, be done, just skip to the end. If I didn't include this break, what it would actually do is it would go into the next one and write out sophomore. And if I didn't include this break, then it would go to the next one and write out junior. So no matter what, it'll always go on to the next one. I don't want it to do that. I want it to force it to break as soon as I get to the correct output. So you're going to end every one of these cases with a break. Now there might be times when you really do want it to go into the next one, and if you really do want it to go into the next one, then don't include break. But for the most part, the programs you're going to be writing, we will include break. All right, so what happens here is if I really want it to go into the next one, let's say in this case we have freshman, sophomore, and then upper class. So let's forget senior and sophomore. I'm sorry, senior and junior. So what we're trying to find out is, are they a freshman, sophomore, or upper class? So if I put in that the year is 1, it'll do freshman and break, and it goes to the end. If I put in that the year is 2, then it goes sophomore, breaks, goes to the end. If I put in 3, it does 3. There's no code here, but because it keeps going on to the next one, it'll write out upper class. Or if I put in 4, it automatically jumps to here and does upper class. So no matter if I type in 3 or 4 in this instance, it will automatically route up upper class. And then we also have a default, and the default is going to be, what do we do if it doesn't match any of these? And so in this case, the default is going to be invalid year. So if I type in something like the year is 5, it doesn't match any of these 4, so this is what it's going to do. We can also use switches with enumerations. And what we're going to do is make it where we can have output based on the enumeration. Usually you'll see this with things like your error codes, things of that nature. All right, so in this case we have an enumeration called major. Accounting is 1, CIS is 2, English is 3, math is 4, marketing is 5. All right, so we come down into here, we're going to declare major. We're going to declare that we have a string for a message, and then we're going to write out onto the screen, enter a major code, and we're going to read some input. We convert the input to an integer and put that into major. So let's say I put in 2. All right, so I'm going to put in 2, which 2 should be CIS. All right, so switch major, major. And notice we have to declare how we cast it. So we're casting it as major. Alright, so this major here, lowercase, is the value of what they entered. This major here with the capital M is the enumeration. Alright, so what we're going to do is we're going to look at our cases, and we're going to look at the case 2. Now, if I cast this as the enumeration data type, then it will automatically convert whatever I typed in as 2 to CIS. Now, it's actually not just simply CIS, it's major.cis, because the major is the data type. Alright, so we're going to say major.cis. Okay, so here's major.cis, and notice we have a case here with no code inside of it. Alright, so what that means is that if I type in CIS, it will automatically go to the next line of code, which is marketing. Now, I didn't type in marketing, I typed in CIS, but what will happen is it will say message, major is in the business division, then it breaks and it goes to the end of that section of code. And so then what it will do is it will actually write out on the screen whatever that message was. So the idea here is that I can actually simply select what major I'm in and then display what business or what division that particular department is in. So you would end up with something like this. Alright, so we talked about conditional operators. These are the if-then statements. We have the syntax. We can actually make it a little bit shorter. We could say something like, if something is true, then we do something. We actually can put that as a one-line expression. So if we have an if statement that we need to test, and we have a single line of code to see if it's true, and then a single line of code if it's false, we can do it as one line. So whatever we're trying to test, whatever our conditional statement is, then, our comparison statement, and then whatever the result should be if it's true, and then whatever the result is if it's false. So what I can actually do is I can do this all in one line, and we're going to write something out to the screen. So what it's saying here is, if the test score is greater than or equal to 60, is it? Well, if it is, then whatever here is what gets written out. So we're going to write pass. Or else, we're going to write fail. So what happens here is, let's say we enter a grade of 75. It tests, is 75 greater than or equal to 60? Yes, we write pass. If I put a grade of 30, is 30 greater than or equal to 60? No, so we go over here to the false section and we write fail. It's the same thing as having the 4 lines of code for our if-else statement with 1 line of code in each one of them. This will only work if we're trying to use a conditional that has, a selection statement that has 1 line of code for the if statement and 1 line of code for the else statement. Alright, we can also use a not operator, and not just simply means that something's not true. Sometimes we don't want to test for if it's true. Sometimes we want to test if it's false. And the way that we do this is we use the exclamation point. And essentially what we're doing is we're reversing our Boolean expressions. So we're saying if something's false, then we do something. Now, we want to try to make it where we always test if things are true, but sometimes it'd be easier to test if it's false. So, like I said, get in the habit, try to test if things are true, but if it makes your code a lot shorter, then go ahead and test to see if it's false instead. Alright, so some of the things that you'll have a problem with, your selection of statements are going to be where you try to test if something is true and you'll use a single equal sign. Remember, the single is an assignment, the two equal sign is a comparison. The next thing is a lot of people will enter a semicolon at the end of the if statement, and remember the if statement contains other things, so you're not going to put a semicolon at the end of your if statement. You're going to open and close a set of curly brackets. And then the other thing is that we need to always include our ands and ors, and we need to test for some sort of Boolean expression on both sides of the and or. Alright, so in this case here, we're going to do what's called a range check. And a range check is simply if the sale amount is greater than or equal to 1,000. Okay, so let's say I have a sale amount of $1,200. I want to test to see what my commission is. Alright, so in this case, I'm simply going to say, is 1,200 greater than or equal to 1,000? It's true, so therefore my commission is 0.08. But remember, we have that no fall through rule. And we also have this thing where it's going to keep going down through our different if statements. So if I make these all as different if statements, I'll say if the sale amount is greater than 1,000, that's true, then it makes it 0.08 for my commission rate. But then this is the end of our if statement here, which means it will evaluate this if statement here. And then it says if the sale amount, 1200, is greater than or equal to 500. Well, that's true, so then it makes my commission rate 0.06. Then it goes on and evaluates this one. Is if 1200 is less than or equal to 499, that's not true, so it ignores this one. But what would happen is I would never get this 0.08 commission rate because it would always evaluate, so this is greater than 500, which would be true, and then it would evaluate as 0.06. So instead, what you want to do is you want to do if the sale amount is greater than or equal to 1,000, then do this. Else if, then we're going to test to see if it's over 500. That way, if I put in 1,200, it'll do this and then not do these else's. But if I put in, let's say, $600, this is not true, so it ignores this and goes to the next one. And then it says, is 600 greater than or equal to 500? Yes, it is, so 0.06. If I enter something like $100, $100 is not greater than 1,000, so it ignores this, goes to this else. $100 is not greater than 500, so it skips this and goes to this else, and then this is our commission rate. So whenever you're trying to use if statements, sometimes you can get away with using separate if statements. Other times you have to embed them as an else if statement. So get in the habit of using if and then else if and then an else. Now you'll notice in our last one, this is what is considered to be a default entry. So what will happen is if none of these are true up here, it will automatically be this one at the bottom. Alright, so we're going to try to figure out a couple of problems. We need to know when we need to use ands and ors. Alright, so we want to print an error message when an employee's hourly pay rate is less than $5.65 and when their hourly pay rate is greater than $60. Alright, so in this case here, we want to print an error when it's less than $5.65 and when it's greater than 60. Alright, so let's say I put in a pay rate of $3. $3 is less than $5.65. If I were to do and, I would say is 3 greater than 60, and this will never evaluate as true. So if we look at this and is not the appropriate way to do this. What we're going to do is we're going to do an or instead. So if I put in $3, that's less than $5.65, it'll write there's an error. If I put in $80, it's greater than 60, it'll put that there's an error. But if I put in something like $20, 20 is not less than $5.65, 20 is not greater than 60, therefore it won't write this line. Okay, some other problems. Make sure that whenever you try to use the not operator, in this case it says if the sales code is not A and the sales code is not B. Now what will happen here is if I type in A, this one is false, this one's true. If I type in B, this one's true and this one's false. There's no way to get a true up here. So this would never happen. I never get a discount. But now if we come down here, if we say if not the sales code is equal to A or the sales code is equal to B, so if I put in B, okay, sales code equal to B, this is false, but this one's true, and so this is true, and then so if it's not true, then we put in here. Alright, so then what we're going to do is we just need to evaluate all of our expressions using the not operator the proper way. And the problem with this is it gets really confusing. But if I were to do it the other way, if I were to do something like if the sales code is equal to A or the sales code is equal to B, then we do something here else and then put our discount below, it makes it a little bit easier to figure out our code. Alright, so we're going to start using these in our programs. We're going to make if, else, and switch statements. And we have some types of controls that we're going to use. We're going to use buttons. We can use radio buttons. We can use list boxes. We'll get more into those here in a little bit. But in this case, we have a program to figure out a discount. So we're asking for the person's age and then the movie rating that they're trying to go to. Alright, so in this case, the age is 11, which it was, I believe it had to be less than 12. So if they're less than 12, they get a discount. And so what we're doing is the same code that was used for the console application would still get used for the GUI app. So the person here is 11 and the movie is a G, therefore they get a discount. So when you click on the button, it tells you there's a discount. But if they type in 13, it wouldn't matter what movie it is. If they're 13, they don't get the discount. They only get it if they're less than 12 or greater than 65. So our code would look something like this, where we do our string.format, and then we put in our code where we say when the age is 12 and the rating is G, then they get the discount. And if you notice, they've actually used our line breaks in here. So we have escape sequence, so that way our code looks a little bit nicer. I'm sorry, output looks a little nicer on the screen. All right, so we're going to go ahead and build some applications that make decisions. And I'm going to start off just by simply asking for the person's name, outputting if they're old enough to vote. I want to do things like if they're old enough to drink, if they're old enough to vote and to drink, and things like that. So I'm just going to make a console-based application for now, and then I will start building some GUI-based applications. Okay, so I'm going to call this voting age. Now in yours, you're going to call it your last name, and then whatever the week is. So in this case, week 5_N1. And so this program is just simply going to ask if the person is old enough to vote or not. Sorry, not ask that. We're going to ask what their age is so we can determine if they're old enough to vote or not. All right, so we're making a console-based application. It has a couple of parts to it. The first part is to prompt the user for their age and read it in to a variable. So what are we going to call it? Well, if we're reading in a text string, we're going to call it strAge. Okay, the next thing that we're going to do is we're going to try to figure out if the age that they entered is greater than 18, then we're going to say they're old enough. So we're going to do our comparison. So compare their age to minimum voting age. Okay, so we're going to start off. We're going to prompt the user. So console.write, how old are you? And remember to put a couple of spaces here after your prompt, so that way the user has a little bit of space between the end of the how old are you and where they actually start typing. Alright, so we need to type that in, and we're asking the user how old they are. Alright, so once we know what they enter, then we have to put that into a text string. So what I'm going to do is I'm going to create a brand new text string variable, and I'm going to call it strAge, and I'm going to set that equal to console.readline. Okay, so we're asking them to enter something. We read the line, and then we put that into strAge. Now I can't compare the strAge to 18, so I have to convert that to a number. So I'm going to make another value for an integer called intAge. And the reason it is an integer because when we talk about our age, we say I'm 15 or 21 or 36 or however old you are. We don't talk about I'm 36.2 years old. So it's going to be an integer value. And I'm going to set this equal to, it's going to be equal to this converted to an integer. So I'm going to have to use a convert to int32. And what am I converting? I'm converting strAge. All right, so now I have a string strAge, which is what the user typed in. I'm going to take that, convert it to an integer, and then we'll put it in intAge. Now that we have their age, now we're going to come down here to compare it. So we're going to make an if statement. So if their age is greater than or equal to 18, so if intAge is greater than or equal to 18, then we're going to do something. You'll notice when I pressed enter, it automatically indented here. Now the indent is actually waiting for me to type. Now I'm just going to type it as one line of code. I will show you with and without the curly brackets. So if they're older than 18, then we're going to do a console.writeLine. You are old enough to vote. Okay, so here we have console.writeLine, and you'll notice as soon as I put the semicolon here, it actually did end this one. Now, if you don't use a semicolon, you have to, if you don't use the curly brackets, you have to put a semicolon. If you use the curly brackets, then you don't need a semicolon. All right, so what we're telling it is ask the user how old they are, read in whatever they type, put it in strAge, convert their age from a text string to an integer and stick it into intAge, and then compare. If intAge is greater than or equal to 18, then we're going to put are you old enough to vote. All right, so let's go and run it. Program runs, how old are you? I'm going to put that I'm 16. Now, it didn't do anything. Well, why didn't it do anything? Well, let's get back to that in just a minute. Let's try 18. Okay, now it came up, it said I was old enough to vote, but what I'm going to do is my console.read, so that way it waits for it. So I'm going to put in 16. It doesn't do anything. I'm going to put in 18, you're old enough to vote. Put in 100, you're old enough to vote. Okay, so what I'm doing is I'm comparing how old they type in to 18, and then we're stating if they're old enough to vote. And we're not doing anything if they're not old enough to vote. So this is a single alternative. Now, if I want to make this a dual alternative, then what I can do is I can say else, and then what do we do if it's an else? So console.writeLine, you are too young to vote. Okay, so now let's try this. So now I am 16, you are too young to vote. Okay, so it did what I wanted it to do. The catch is I can do this where I indent if I only have one line of code that I actually want to put into here. But what I want to do is I want to start getting in the habit of actually using the curly brackets. And so to do this, I'm going to put the curly brackets like this. Now what it will do is if their age is greater than or equal to 18, all of the stuff in the middle of the curly brackets actually gets run. So what I can do here is, and like I said, I don't have to put a semicolon at the end of my curly brackets because that is designated as the end of my block, but I'm designating that all of the lines of code in here belong to that block. Okay, and then the same thing here with my else statement. I put that inside of curly brackets. Now I can see this is the else, and all the stuff in between these two brackets is what belongs to the false side. This is our positive side, so that's what we get there. Alright, so run this. How old are you? Same thing. Now, whenever you do one of these evaluations, I want you to do 3 tries. I want you to try your limit, which the limit is this number 18. I want you to try one above your limit and one below your limit. And the reason for it is I'm going to make a simple change here. I'm going to make this int age is greater than 18. Okay, so I'm 21. I should be old enough to vote. Yay, I'm old enough to vote. It's working. Great. We're done. Let's submit it. All right, well, the problem is if I don't test my limit, I expect that if I'm 18, I should be old enough to vote. So if I type 18, wait a minute, what do you mean I'm too young to vote? So now by testing my limit itself, then I can verify whether I should have used a greater than or a greater than equal to. And in this case, I can see that because I used greater than, that it actually ended up breaking the program because now it's not valid. So it has to be greater than or equal to, and the only way that I'm going to know that is if I test my limits. So always test the limit, test the number above the limit, and the number below the limit. Alright, so I also have one more thing. I have this number 18, and the question is, what does the number 18 represent? This is what's called a magic number, and a magic number is just simply a number that shows up out of nowhere that has no significance. We don't know why it's there, and 10 years from now when I come back and look at the code, I'm going to go, why did we put 18 in there? Especially, let's say they change the voting age to 21. Well, if they change the voting age to 21, and I reference the voting age in 50 different places in my program, and I just reference it as 18, I have to go touch every one of those little places to change my voting age. We don't want magic numbers. You always want to compare two things based on variable names. So what I'm going to do is I'm going to declare a variable. I'm actually going to declare a constant, and my constant here is going to be an integer value, and the integer value is going to be int voting age, and we're going to set this equal to 18. Okay, so now what I'm going to do down here is I'm going to compare int age not to 18 but to int voting age. So now what this does for me is it makes it where if the voting age changes, I only have one place in my program where I have to change the age. So now what I can do is I can come down here and say, okay, well, this is an integer value. Okay, I'm comparing two integers. It's the voting age. Oh, hey, that's what it is. So 10 years from now when I come back and look at the code, I can see why I used that there. All right, so let's go ahead and run it. 18, you're old enough to vote. So it knows that 18 is the age because I set it equal to this. And what I'm doing is instead of a magic number, I'm just simply going to create a constant for it. Remember, a constant just simply is a variable location where its numbers don't change. Sorry, it's a memory location where its value doesn't change. And so by doing it this way, it's the same thing as me typing the literal 18 down here. But if I type a literal 18 down here, that magic number makes it where I can't figure out what it's for later on, and it also makes it where if that voting age ever changes, I have to find all the places. So please get in the habit, whenever you have two comparisons, they should be two variable or a variable and a constant comparison. You shouldn't use literals unless it's just something you're doing real quick to try to figure out an outcome. Alright, so I want to change this just a little bit. Let's say instead of trying to find out if they're old enough to vote, I want to find out if they're too young to vote. Alright, so what I can do with this is I'm going to use our not operator here in our if statement. And so what I'm doing is I'm telling it if the age, we want to make this backwards. So I'm saying if the age is greater than or equal to the voting age, not. So if that's not true, then we're going to do something. So what I'm going to do is I'm actually going to reverse these two lines. So I'm going to take my console.writeLine from here, move it up here, and take this one and move it down here. So I'm reversing. Now what I'm trying to do is I'm not trying to evaluate if something's true, I'm trying to evaluate if it's false. So if I type in an age of 16, okay, so 16 is, if I look at this, 16 is less than the voting age. So what I would look at would be, is 16 greater than or equal to 18? False, but I'm negating that, so now I'm making it true. So therefore I would be looking at, am I too young to vote? And then if this is false, if this would be true, then now we would look down here. So what we're doing is just simply swapping if I'm trying to evaluate if it's true or if it's false. It gets really confusing if we try to evaluate for the not. So get in the habit of trying to evaluate if something's true, and it'll be a lot easier to follow your code and troubleshoot it. But what I want to show to you is if I type in that I'm 16, I'm still too young to vote. And the reason for it is my 16 is less than the voting age, which is false, but by putting our exclamation point, by putting the exclamation point here, we're telling it, hey, reverse this, and so we're now evaluating if it's true. All right, so like I said, it gets a little confusing if you use the not statement, but it does allow us to reverse them like that. All right, so I want to put this back the way that it was before. So let's get rid of our not statement. Make sure that it still runs. Okay, I'm old enough to vote. Remember I said test above, below, and the limit itself. And they're all still working, so I know that this is good. So I want you to save this. This is number 1. And this is one of the ones you're going to be submitting to Blackboard today. Alright, so I'm going to make another program, so I'm going to go ahead and close this one. So close solution. I want to make a new project. Once again, I'm going to make a console-based application. This is number 2. Alright, so in this program, what I want to do is I'm going to ask the user to enter a grade, and then I want to convert that grade to a grade letter. So I want to say if you type in a grade of 76, it should be a C. And I'm going to assume that it's a 10-point scale. Alright, so what I'm going to do is, first thing is our declare variables. I am going to ask user for grade. And then I'm going to perform selection statements to figure out what their grade is. Okay, so we're going to determine their letter grade. Alright, and then the last thing we're going to do is output. Okay, so what I want to do is I want to ask the user for a grade. Alright, so if I'm going to ask them for a grade, then I'm going to make a new string value called strGrade that is equal to console.readLine. Okay, so before I can get the grade from them, I need to prompt them. So write, enter your grade, or let's say enter a score between 0 and 100. Okay, so we're going to ask them to enter a score between 0 and 100, and we're going to read that and we're going to put it into strGrade. Alright, so then strGrade is a text string, and we need it to be a number to perform calculations on it. So I'm going to put this into an integer value. I'm going to call it int grade, and that's equal to convert.toInt32 and strGrade. All right, so ask them for their score between 0 and 100. Read that in, stick it into str grade. Take str grade, convert it to an integer, and stick it into int grade. All right, so now what we can do is we're going to perform if statements. I'm going to show you the wrong way to do it and then a right way to do it. Okay, so I'm going to say if int grade, parentheses, int grade is greater than or equal to 90, then we're going to say console.writeLine, the grade is A. All right, so we're looking at if the grade is greater than or equal to 90, then the grade is A. All right, so if int grade is greater than or equal to 80, console.writeLine, the grade is B, and so forth. So now I'm going to say if int grade is greater than or equal to 70, console.writeLine, the grade is C. And then if int grade is greater than or equal to 60, then we're going to say console.writeLine, the grade is D. And then we're going to say if int grade is less than, actually it's going to be less than 60, then we're going to say console.writeLine, the grade is F or E or whatever the lowest grade is. Okay, so we're going to declare some variables here in a minute, but for right now what I want to do is I want to compare these. And so what we're going to say is if the grade is greater than 90, then they should have an A. And then if that's not true, then if it's greater than 80, then they should get a B. And if that's not true, then we're going to go to a 70, and that should be a C. And if it's not true, then we go to a 60, and that's a D. And anything less than a 60 is an F. Okay, so I'm going to run this, and I earned a score of 65. Oops, forgot my console.read. Okay, so let's run it. I got a grade of 65. The grade is D. All right, it's working. Great. All right, so I run it again, and this time I got a 96. Now what you'll notice is the grade is A, the grade is B, the grade is C, the grade is D. Why did it do that? Okay, well the reason it did that is it went through and it said if my grade is greater than 90, then we write out the grade as A. And then it goes on to the next line, and the next line of code is this one right here that says if it's greater than an 80, then we rate a B. Okay, well that's true, so it's definitely higher than an 80, then we're going to rate a B. Okay, then we can say if the int grade is greater than a 70, then the grade is a C. Well that's true, so we're going to do that one. And if it's greater than a 60, then we rate that as a D. And if it's less than a 60, which is not true, so that doesn't write this out. All right, so there are a couple ways I can fix this. I'm going to fix it a longer way, then I'll fix it a shorter way, and then I'll make it even shorter. All right, so first one is I'm going to take int grade, and not only do I need to know that the grade is greater than an 80, but in this case, for this one to work, I also need it to be less than a 90. So it has to be greater than 80 and less than 90. And pay attention to the word and or. Figure out which one you need to use. So I'm going to say ampersand, ampersand. Okay, int grade is, let's say, less than 90. All right, so now if I put in 85, 85 would be greater than or equal to 80, and it would be less than 90, so it would be this. Okay, so let's do ampersand, ampersand, int grade is less than, for this one it should be 80. Oops, forgot my space. And then this one should be ampersand, ampersand. So if it's greater than 60 and int grade is less than 70, and then this one here, anything less than 60 is just no. Okay, so if I run this, okay, so now I get a 65 as a D. Run it again. I get a 75. Oh, it's a C. Okay, so that's working. I test all of them. 85. That's a B. Okay, that works. And then 95, and that's an A. Now, like I said, I always want to test my limit, so if I type in a 90, I should get an A. So you're going to test your limit for every one of these. Okay, when I said test the limit, I said test the limit, one above it, one below it. Okay, so here's a limit of 90, so I'm going to do 1, 2, 3 evaluations. So I'm going to try it 3 times there. Here's another limit, so 3 more. So now we're up to 6 times running it and trying it. Here's 3 more, so now I'm up to 9 times trying it. Here's 3 more, so now I'm up to 12 times trying it. You can see how this keeps adding up. I want to shorten my code a little bit. To shorten my code, what I can do is I can get rid of these ands, and instead of saying and, I'm going to change this from if to just simply else if. And now what this does is if this is true, then do this. Otherwise, do this. And then if this is true, then we'll do this. And it will only perform the else if this one is false. And what I can do is I can make each one of these an else if. So this is an else if, and then this last one, we get rid of the entire comparison statement here, and we just simply say else. And what this is going to be our default. So if you get a greater than a 90, then it's an A, and then it's done. It finishes. Else, so if I didn't get greater than a 90, then I'll go to the next one. So else if I got something greater than an 80, it's a B, and then that would finish if that was the case. But if I got something lower than an 80, it'll go on to the next one. Get something less than a 70, it goes on to the next one. Get something less than a 60, it goes on to this one. And this one is going to be your final output if none of these up here is true. All right, so let's try this. I get a grade of 95, it's an A, and it's done. I get a grade of 85, it's a B. Get a grade of 75, that's a C. Get a grade of 65, that's a D. And get a grade of 55, it's an F. So instead of having my compound comparisons, where I have to compare that it's greater than or equal to 80 and less than 90, then all I have to do is just simply say else if. So do this one. If this one's true, great, do this and then be done. If this is not true, it goes on to the next one. If this one's true, it does this and it's done. If this is not true, it goes on to the next one. If this is true, do this and be done. If this is not true, it goes on to the next one. So forth. It keeps going all the way to the end of all of your else if statements. Now you can imagine how long this is actually going to get if I have 50 different values that I'm trying to evaluate for. And then on top of this, I also have this thing here, this 90, which I said just a couple of minutes ago was a magic number. So what I need to do is I need to get rid of this number. And I'm going to come up here to my variables, and I'm going to declare a constant for an integer value. So we'll call this grade A. And this is the minimum grade to get a minimum. So we'll say grade A min. And we're going to set this equal to, oops, sorry, this is an integer value. And we're going to set this equal to 90. Okay, so then I have a constant here that I'm going to make as an integer called int grade B minimum. And that's equal to 80. Constant integer int grade C min is equal to 70. Constant int grade D min, and that's equal to 60. Okay, and I don't need to declare F because F doesn't have a minimum. I could have a negative score and it would still be an F, anything less than a 60. So now what I do is I come here to this 90 and we're going to change this to int grade A minimum. This one is int grade B minimum. This one's int grade C minimum. This one's int grade D minimum. So now what I can do is I can go through my code and see that int grade, if it's greater than the grade B minimum, then this will occur. So I didn't change how the structure of my program is. I've made it where if we decide that now we're not at a 10-point scale, instead of being 90, 80, 70, 64, some schools do 94, 86, 78, and then 70 here for your D. So it just depends on the school and how they want to scale. And all I have to do is just change it in one spot, and it affects everywhere in my code. All right, so just to make sure it still works, a 90 should still be an A, an 80 should still be a B, and so forth. So now what I've done is I've made my program where all I have to do is change this one location up here for each of these minimum values, and by doing that, it will affect all the other places in my code. All right, so go ahead and save this as your second one, and we're going to modify this for the third one. All right, so my program works, but the thing is that let's say where we have the grade is A, I want to change that and just make it say grade, colon, space, and then the letter. Then what I'm going to have to do is I'm going to have to touch every one of those outputs to make the change to it. And instead of doing this, what I'm going to do is I am instead going to create a string value to hold the grade letter. So I'm going to say str grade letter. Oops, that's a string. And so I made a new variable here called str grade letter that is of a data type string. And instead of doing a console.writeLine here, I'm going to say that str grade letter is equal to A. And so what that does is now it puts in the letter A for this variable location. And I can do the same thing for all of these. So now this is our B. You can do the same thing for C. So str grade letter is equal to C. Str grade letter is equal to D. And the last one, str grade letter is equal to F, or whatever the lowest grade is. Okay, so now what I'm going to do is down here under output, now I'm going to do my console.writeLine. Okay, now my console.writeLine, what am I writing? Well, I'm writing out the grade is, and then now I can use my substitution, period, and then the grade is actually going to be str grade letter. So now it does the exact same thing, but now what I'm doing is if I want to change from the grade is on all of these to something like grade colon, then I can just change it here in this one spot and it will change the output for all of these. That way they'll all be consistent. All right, so let's try it. My grade is 90, the grade is A. I still get the same type of output. Okay, so I got a grade of 50, the grade is F. All right, but like I said, if I want to change the way that it's formatted, I come down here and I say something like grade colon, and then I run this. Now I have 90, grade colon A. All right, well, let's try it for 50 again, grade colon F. So now what it does is it changes the output for all of the scenarios, even though they're, it changes the output for all of the scenarios without me having to go back and touch every single one of them. All right, so go ahead and save that as your third program, and then we're going to go ahead and make another one. All right, so for the next program, I'm going to work through the example in your textbook in figure 4-23. It's the one where they figure out what major it is and what division it belongs to. Okay, so they start off by creating an enumeration, and in this case it's called major, and the enumeration has different departments in it. And so we start off with accounting, and that's equal to 1. There's CIS, there's English, math, and marketing. Okay, so those are the departments. So now accounting is 1, CIS is 2, English is 3, math is 4, and marketing is 5. Now the catch is my enumeration does not belong inside of my main. My enumeration actually belongs to the entire program. Okay, so what I'm going to do is I'm actually going to move it out of here and move it up to this level. So it goes before my main method, because what happens is the main method only runs when we actually perform some sort of function on it. The enumeration loads when the program loads. All right, so what I want to do is I want to declare a value to hold a major, and then I'm going to ask the user to input a value to that major. And then based on their major, then we'll decide what department they belong to. Okay, so I'm going to declare variables. I'm going to ask the user for the, what are we asking for the major? Okay, and then we're going to put that into a variable location. Then we will decide which department they belong to. Okay, and then we're going to do some sort of output. Okay, so I'm going to ask the user to tell me what department that they're in. So I'm going to say console.write what department. I'm sorry, what major. Okay, so we're asking them what major that they're in, and then what we're going to do is we are going to make a variable location to hold the major. Now the major is going to be an integer data type, so I'm going to say integer int major, and that's going to equal to whatever they typed into the console. So I'm going to do this 2 lines to begin with, and then I will break this down into 1 line. So I'm going to say str str major, and that's going to equal to console.readline. So we're going to read that in. Then on the next line, we're going to take this str major and we're going to convert it. So we're going to convert to int 32 and then str major. Okay, and I want to take these 2 lines of code and I want to combine them together. Well, look at what's being substituted here. We have str major, str major. Str major is equal to all of this stuff here. So what that means is I can take this here and I can cut it and instead put that right here. And what that does for me is it gets rid of 1 line of code. So we're going to ask them for their major. We're going to read it in from the screen. We're going to convert it to an integer and stick that into the integer value. Okay, so we need to tell them what values we have, and in a real program we would say marketing equals 5, math equals 4, and so forth. In this case, we're just simply going to assume they already know that. Alright, so what we're going to do is decide what department they belong to, and the way that we do this is by using what's called a switch. Okay, so we're going to make a switch, and our switch will have a it will look at a specific variable, and the variable that we're looking for is this int major right here. Okay, the problem is if I do int major is a number. So if they enter the number 3, then I would be typing the 3 here and be looking for it. But the problem is by looking at the number 3, I want to compare these up here by name. I don't want to have to look at 1, 2, 3, 4. I don't really care what the number is. Okay, so what I'm going to do is I'm going to cast this thing as our actual enumeration up here. So that's major. Okay, so now what we're doing is we're taking whatever number they type in, 3, casting it as a major, and now it's not 3, it'll be major.english. And what that does is it allows us to compare not based on some number, but based on the actual name of the department. Okay, so our switch is going to be contain curly brackets, and we're going to use what are called cases inside of it. So the accounting, CIS, and marketing all belong to the business division. And then English and math both belong to humanities. And then if it's some other number that doesn't exist, then we need to tell them that's not right. Okay, so what I can do is I'm going to place a case in here for major dot, and notice when I do dot I get accounting. Okay, and so what is the case for it? Well, the case is going to be that we're going to make a message, and the message is going to be major is in the business division. Okay, so now if they type in accounting, which is 1, so if they press 1 will get converted to major.accounting because we're casting it that way. And if they typed major.accounting, if what they type as a 1 gets converted to major.accounting, then we're going to run this. Okay, so what is str message? Well, we need to have something to hold that for us. Okay, so str message is going to be a variable that we need. It is a string data type, and what this is going to be is it will allow us later to actually perform some sort of output. Alright, so now what we're going to have here is that we have our first case is for accounting. We need the ones for the other possible outcomes. So we're going to say case, and then let's see, we're going to have case is major.cis, and then its case is going to have str message is equal to major is in the business division. It's the same thing. Okay, then we have a case of major dot, let's see, marketing is also in the same department, so marketing, and its str message is going to equal to, same thing, major is in the business division. Okay, so what I'm doing is just simply putting here that those three departments belong to the business division. Okay, and then we have a case for English, so major.english, and its str message is going to equal to major is in the humanities division. And then we have a case for major.math, and its str message is equal to major is in the humanities division. Okay. Alright, so now what we're going to do is we also need to have a default message. So what do we get if whatever they enter doesn't actually exist? So we're going to say default, and then the default str message is going to be equal to department number is invalid. Oops. And credit. Oh, because I didn't put it in quotes. Department number is invalid. Alright, so I'm defining cases for all of these, and what's going to happen is we're going to ask the user for a major. They enter a major of 1. Major 1 gets converted to accounting, so it will look at major.accounting and it'll say the major is in the business division, and then that should be it. That's all it should show to me. Alright, so we need to get this out on the screen, and for us to get this out on the screen under our output section, we are going to do console.writeLine and then str message. So we're going to output the message. Alright, so let's go ahead and run it. It says there are build errors. Okay, so the question is, why do we have build errors? Alright, so now if you look at these, it says control cannot fall through from one case label to another. Alright, so what that means is that for some reason it's looking at this case accounting, case major, case marketing, case English, and so forth. And the question is, why are we getting this type of error? And the thing is that right now what it's doing is it's going to look at accounting. If I type number 1, it will put whatever is str message, and then it will also put the next one, and then it will also put the next one, and then it will also put the next one. Remember I said that there's that no fall through rule? Well, what happens is when we get to the end of this str message, our next line, we need to break it. Alright, and then the same thing with this next one. The next one we need to break it. Alright, and the next one we need to break it. And the reason for this is to tell it that, oh hey, we need to stop running at this point. And even our default still needs to have a break. So every one of these, you should see a break in here. And so what it will do is it will allow it to run just this one, it breaks, and then it won't display the other lines of code. Alright, so let's try to run it. It runs. So what major? I want number 1, which is accounting. Press enter. Major is in the business division. Alright, so major number 2 is CIS. That should be in business division. Major number 5 should be in the business division. Major number 3, which is English, should be in the humanities. Number 4 is math, and that should be in humanities. And if I enter department 16 or any other number, it should say that it's invalid. Okay, so it is working, but the thing is if I want to change this text here, majors in business division, I have to change it in every place where that gets affected. Alright, so what I can do is instead of doing this, I can use that no fall through rule, and I can actually delete this code. And I'm going to delete this code here. And now what I end up with is that if the case is major or CIS or marketing, then do this. And I can do the same thing down here because I want English and math to be the same. So the very last one is the one that gets the message. Okay, so the first one here for English, I'm going to delete that section of code. So if the case is English or the case is math, then we're going to display this on the screen. All right, so let's try it again. Number 1, business division. Number 2, which is CIS, business division. Number 3, which is English, humanities. Number 4, which is math, humanities. Number 5, which is marketing, business. And then lastly, any other number is invalid. So now what I've done is I've made it where we can ask the user for an input, what major number, and then based on their major number, then we can display some sort of output. Now where this really comes in handy is when we start using drop-down boxes. Because when you have a drop-down box, you do something like select something, and then they have a list of items, and then they can select one. And every drop-down box item has an index number, and the index number would line up with these. So all they have to do is just simply select one out of the list. We just simply know which one is which, and then based on their value in the enumeration, we can get the text to come as the output. Alright, so the question is, what is this doing behind the scenes? What I'm actually looking at here, major.accounting, remember, is the number 1 up here. So what I can do is, instead of looking at major accounting, I want to look at if somebody enters a number 1. So if they enter a number 1, then we're going to display this. Now the catch is, in this case, the number 1 is actually the int major here, and we have to cast it as the enumeration data type. Okay, so what I'm going to do is major, cast it as major 1. Okay, so if they enter 1, what is 1? Now I don't know what 1 is. I have to go and look it up. Okay, but it still works the same way, as long as I spell it right. It still works the same way, where if I enter the number 1 is accounting, which accounting still belongs to the business division. So this is a little more confusing because I have a number here, but if I were to put this in as the major.accounting, this is a lot easier for me as a human to figure out what it means. But behind the scenes, the system has to do a lookup, find out that that's number 1, and then it can perform its comparison based on that as the number 1. Go ahead and save this program, and then we'll make one more. Alright, so our next program is going to be number 5. And in this program, I want to ask the user to enter a number. And I'm going to compare the number to a randomly generated number in the computer system. Because what I want it to do is I want the system to automatically pick a number for me between some minimum and maximum range number. And then what we're going to do is we're going to see if I can guess what that number is. So kind of make it like a guessing game. There's also a game called high-low where you can get the system to automatically pick a number, and then we can guess if our number is right or if it's too high or too low. We're just going to do the basic version of it right now. And to do this, I need to use what's called a randomized timer, or random number generator. Okay, so to do this, I'm going to use a class of objects called random. And if you notice, if I just start typing RA, I get random in the list. And what I need to do is I'm going to give it a name. And one of the things you need to think of is I have these class of objects called random, which, remember, a class of objects is like having a blueprint. And a blueprint is not a real object. A blueprint is just simply the plans to make the real object. Okay, so I have a set of blueprints for random items. I'm going to make a new random item that I give a name. And so I'm going to call this something like random number. Okay, so I'm going to call it random number. And I'm going to set it equal to a new random. Okay, now if I put the parentheses after this, this is a new class of objects, and I'm setting equal to I'm setting a new class of objects, random, and I'm making one new object called random number. So what happens is I will end up with a new object here in just a second. So if I type random, you'll see I now have random number, and this is an object that I can actually play with. Now it's a variable, but it's an object. We will get more into objects later in the semester, but for right now you need to know that we can get random numbers. Okay, so now to actually play with this thing and to get it to actually generate a new random number for us, I'm also going to I'm going to make a new variable for it. Okay, so this time I'm going to make a new integer value, so int random number. Okay, notice I'm calling this random number. This is the generator, and then this is the actual variable location. Okay, so then what I want to do is I want to take int random number, and I'm going to set that equal to whatever a random number generator is. So in this case, I call it random number dot, and then we have next. And so I tell it to generate the next random number. And I have to give it a minimum and a maximum. If I open the parentheses here, you do get these contextual helps. So max value, and then here this one says min value and max value. This is what it expects. So I want a number somewhere between 0 and 100. I want it to declare a random number between 0 and 100. All right, so let's just simply write that out to the screen. So we're going to write int random number out to the screen, and just so you can see what happens. Oh, before I do that, I need my console.read, so that way it stays on the screen. Start, and there we go, it goes 75. Okay, next time I run it, it's now 86. Run it again, 89, and so forth. Okay, so what I want to do is I want to generate a random number between 0 and 100. That's what this section of code did. Okay, so then my next thing that I want to do, and I'm going to leave this console.writeLine for now just so we can see what the random number is, but we'll remove it later. Ask the user for a number between 0 and 100. Okay, then after we ask them for the number between 0 and 100, compare the user number to the random number. And if they got the number right, then great, we're done, and we say congratulations. If they didn't, then we're going to tell them if the number is not correct. Now you can also do the number is too high, number is too low, and get them to guess. Later in the semester we'll actually make this game more complicated. But for right now, what I want them to do is I want to ask for a number. So I'm going to say console.writeLine, or .write, enter a number between 0 and 100. Okay, and actually a couple spaces here just to give them room. And the next thing I want to do is I want to take whatever they put in and I want to put that into an integer value. So I'm going to make a new integer data type. I'm going to call it int, let's say int guess. This is what they actually guessed. And that's going to equal to, all right, so we need to read something in from the console. It's going to be a text string, therefore we have to convert it to an integer. So I'm going to convert to int 32. What am I converting? Well, I'm converting console.readLine like this. So read in whatever they typed in the line, convert it to an integer, and stick it into int guess. All right, so then what we're going to do is we're going to compare and see if their number is right. So if their number, int guess, is equal to int random number, then we're going to say something like console.writeLine, congratulations. Okay, if not, then we're going to say wrong number. Okay, so create a new random number, stick it in int random number, and tell it to pick a number between 0 and 100. We're going to write it out to the screen just so we can see what it is for now. Console.write, we're going to ask the user to enter a number between 0 and 100, and then they're going to guess. All right, so their guess is going to be converted in from whatever they type to an integer and put in int guess, and then we're going to see if their guess is equal to the random number. If it is, we tell them congratulations. If not, then it's the wrong number. Okay, so my number here is actually 25, so I'm going to enter 25 just to see what we get. Congratulations, because my number is the same as theirs. Okay, so now the next one is it's 44, so I'm going to enter 50. Oops, wrong number. Enter in something like 10, oops, wrong number, so forth. Okay, but if I enter something like 360, okay, it's the wrong number, but what I did is I just entered a number that is not in the correct range. Later in the semester, I'll show you how to fix that, where we kind of force the user to actually enter in the correct range. But for now, we're just simply going to allow them to enter any number. We provide the prompt for them, and then we just simply are going to compare. Did they get the right number or the wrong number? And then we can actually take that and we can extend it so that we can play the game of high-low. So we could even go on further. If we say, if their number is correct, congratulations. Else, if the number is too high, then we tell them too high. Else, if it's too low, we tell them too low, and so forth. So we can modify this game. Instead of just saying yes or no, we can say yes or too high or too low. Therefore, the game of high-low. Go ahead and save this program, and this is number 5. So in this lesson, you learned about a flowchart being a pictorial tool to allow us to see how our program flows, all of our logic. We have if statements that are single alternatives. We have if-else statements that are dual alternatives. You learned about the AND operator and how both conditionals have to evaluate as true for the output to be true. We learned about the OR operator, where if either one of them is true, then the output is true. Remember that the AND operator takes precedence, so what happens is if I use an AND and an OR in the same statement, the ANDs will get evaluated first. We can control the order by putting them in parentheses. We can use a switch to be able to test a single variable to see if something is true. It's kind of like using our nested if statements. And then we're going to use conditional operators to be able to do the abbreviated version of an if-else statement. Remember, it only happens if we have a single line of code for the if side and a single line of code for the else side. We also need to use the not operator so that way we can evaluate for something being false instead of true. And be aware that when you're writing these programs out, that it's very easy to make mistakes if you don't use the correct and or when you use the not operator, it gets really confusing because you're evaluating for the false side. So always try to evaluate for the true side. And then we're going to start using these conditional operators to perform decisions in our GUI applications.